So hello everyone. So this is going our question today. So the question is, using Cayley-Hamilton's theorem, you have to find the value of a raised to 8. Given that A is a matrix, this is a 2 by 2 matrix. Now in the earlier video, Cayley-Hamilton's theorem part 1, we saw the statement of the Cayley-Hamilton's theorem and we also saw one supporting example. So what is the statement? Every square matrix satisfies its own characteristic polynomial equation. Now, in symbolic language, this means that this determinantal value is equal to 0. That is the meaning of this particular statement. That is Cayley-Hamilton's theorem. So A is the matrix, lambda are the eigenvalues, and I is the identity matrix. So we are going to use this theorem to find the value of A raised to 8. So what I will do, I will construct this determinant. You can go to the part 1 video and see how this determinant was constructed. So here I'll just write directly. Okay, and now we are going to expand this particular determinant. So like I said earlier, lambda square minus the trace of A. So trace of A is going to be 0 in this case because minus 1 plus 1 is 0, and plus the determinantal value of A. So if we solve this and we find the determinant of A, how much it will come out to be? Let us just see. Minus 1 into 1, that is minus 1, minus 2 into 2, that is minus 1 minus 4, which is equal to minus 5. So this is the determinantal value. So here I'll write minus 5 equal to 0. So therefore, I get this equation as lambda square minus 5 is equal to 0. Now our statement is that every square matrix satisfies its own characteristic polynomial equation. And in this particular case, this is our characteristic polynomial equation. So the matrix satisfies this equation means what happens? In place of lambda, if I put A, so A square minus 5. Now remember we are dealing with matrices, so I will add a I over here. What is I? It is the identity matrix, okay, unit matrix whose determinantal value is 1. So therefore I can write I like this. Let me just write this again. So this is equal to 0. Right, now we have been asked to find the value of A raised to 8. Remember, this is our question. Find the value of A raised to 8. So what I'm going to do, I am simply going to use this equation which I've got, and I'm going to write A square is equal to 5i. Now I want to find A raised to 8. So we are going to use the law of indices. You know that if I write A raised to m raised to n, then this is A raised to m n. So using that, what I'll do, since I'm interested in finding out A raised to 8, so I'll just raise this on both the sides to the power 4. Okay, so that will give me A raised to 8 is equal to 5 raised to 4 over here, I. And now this will give me A raised to 8 is equal to 625i. And that is the answer to this question. Now if you want, you can express this in matrix form. That means you can write A raised to 8 equals to 625 into the unit matrix 1 0 0 1, and this will give us the matrix 625 0. So we are multiplying 625 inside 0 625. So there are two ways to express this answer. Either you can write it like this, or you can write it in matrix form by just multiplying 625 with the identity matrix. And that's it. That's the solution to this problem, where we were asked to use the Cayley-Hamilton's theorem to find the value of a raised to 8. So I hope you followed along, and you can take a look at the other supporting video, which is basically on the statement of the Cayley-Hamilton's theorem. Thank you for watching.